Alright, welcome to this video, the distance formula. Why does it work? Now, this is something I always like to explain in my classroom. I'm not a huge fan of just being like, oh, the distance formula. How do you find the distance between 2 points? Here's an equation. Use that. While the students generally appreciate it and have no problem using the equation, I always want to know, why does this work? How did we get this equation? Where did that come from? So that's why I want to do this video, and I also explained it in my classroom, of course. But for anyone out there curious, how did we get this giant long equation for the distance formula? This is how we did it. So let's start off with exactly what the distance formula is, just to refresh everyone's memory. We have a big square root quantity y2 minus y1 squared plus the quantity x2 minus x1 squared, right? So that's the distance formula. Now we want to figure out how the heck did we get there. Let me give you 2 points. Let's make it simple points because I am going to be graphing these. 1, 1. Actually, let's make this 1, 2. I like 1, 2 better. 1, 2. And then 5, 7. 1, 2, and 5, 7. I'm going to go ahead and label these x1, y1, as I always like to do whenever I get 2 points, just to make some things simpler. x1, y1, x2, y2, right? Okay, so now we're going to have a graph. We're going to have our big coordinate plane here, right? Hope this all fits in the video. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to plot our 2 points. Right here first, x1, y1 is going to be 1, 2, right there. And then 5, 7. 1, 2, 3, 4, 5. And then all the way up to 7. Right there, right before that, right below that x. So I'm going to go ahead and connect these 2 points with a line. Now, the first thing I see, anytime I see a diagonal line on a graph like this, it sounds crazy, but the first thing I see is the hypotenuse to a triangle. The hypotenuse, of course, being the longest side of a triangle. And that's just what I see. I don't know why, it's just what happens. And that's actually going to help us out a lot with figuring out, why is this the distance formula? So how do I see the hypotenuse of a triangle, you ask? Well, this is exactly how. I just naturally turn these points into some straight lines. I just kind of dot it straight down, dot this one straight across until they meet with each other at this imaginary point right here, kind of making an imaginary triangle out of these 2 points. So you might be wondering, how does this help us? Well, it's not so simple to measure the diagonal without this formula, of course. It's not so simple to measure how long a diagonal line on a graph is mathematically, but it is very simple to measure how long a vertical or a horizontal line is on a graph. Now, whenever we know 2 sides of a triangle, a horizontal and a vertical side like this, then that makes it real simple to find that diagonal side, that hypotenuse side, through the Pythagorean theorem. So let's go ahead and write down the Pythagorean theorem. For any of you guys who might need refreshing memory, Pythagorean theorem, let me write this in marker, it shows up a little better. A squared plus b squared equals c squared, right? So now the a and the b are 2 legs of a triangle, essentially the 2 sides that aren't the hypotenuse. Doesn't matter so much which one is, so I'm just going to call this one a, call this one b. And then over here we have c, the hypotenuse. So this point right here is 5, 7. This point is made up of x2, y2. I know I'm getting this stuff in the way, ignore that. Then this point down here is x1, y1. So let's talk about this imaginary point. This imaginary point is at 5, 5, 2. So that 5, in accordance to these 2 points, is already represented by x2, right? 5 on the y-axis is x2. So we can call that x2. And then we have 7, or sorry, not 7, 2 right here, 2 up on the x-axis, or sorry, I messed up saying this whole thing. 5 is already represented as x2, 5 on the x-axis is x2. The second coordinate, the y-coordinate, is 2, so 2 on the y-axis is already represented by y1 here. So this point is x2, y1. Now the reason this is important is because anytime you want to find out how long a vertical or horizontal line is, you take the farthest out point and you subtract the point that's closer to the origin, right? So we would be taking, for this x-axis, this horizontal line, we'd be taking 5 minus 1, or x2 minus x1. For the a, we'd be taking y2 minus y1. Let's go ahead and write that down. So we have this Pythagorean theorem. Let's kind of write that down, how we're going to represent it here, without actually even having to do any computations. So a can be represented as y2 minus y1, or 7 minus 2, making a equal to 5, right? Now a here, y2 minus y1, is in fact squared in the Pythagorean theorem. So we're going to write that down right there. Let me move my camera over a little bit, get us some more room. Now b is represented by x2 minus x1, of course. Now this x2 is, of course, 5, and x1 is 1, so that would be 4. But let's go ahead and write down, we'll continue with the Pythagorean theorem. Between the a and the b, we do have a plus, so we can write plus there. And then we said b was represented by this x2 minus x1, x2 minus x1. Now in the original Pythagorean theorem, b is in fact squared. Now those two things equal c squared. Now, whenever we solve a problem with the Pythagorean theorem, say we have a squared, or 5, so 25, plus b squared, 4 times 4, so 16. So 25 plus 16 would be like 39, right? We don't just say 39 is equal to c squared. We found our answer. No, we don't need c squared. We just need c by itself. Now, how do you get rid of a squared? You square root it. That cancels it out. Now, what you have to do to one side, you have to do to both sides, right? So we are going to square root this side in the idea of making this just not c squared anymore, just c. So this is how we found the distance formula. This works perfectly, right? C, or d, distance, c, hypotenuse, whatever you want to call it, equals the square root of the quantity y2 minus y1 squared plus the quantity x2 minus x1 squared. That is exactly what we have written down right up here on our paper. So that's how you find the distance formula. If you want to prove that this works, just to make sure, why not, we have the Pythagorean theorem. We found out a is equal to 5, 5 squared, 25, b is equal to 4, 4 squared is 16, 25 plus 16 equals 39, so 39 equal to c squared, square root them both, square root of 39 equals c. Ta-da! When we have our distance formula, y2, 7 minus y1, which is 2, squared, plus 5 minus 1, squared. Simplify this, 5 squared plus 5 minus 1, or sorry, I don't know why I wrote it 5 minus 1 there, plus 4 squared, 25 plus 16, 39. Now I haven't been dropping down this square root the whole time, just in a, to kind of save space. So we get the square root of 39 equal to c here as well in the distance formula. So I hope this made sense. I hope that helped you guys out a little bit with why do we have this big, crazy equation for the distance formula. Hopefully that makes a little bit more sense to you if you were one of those people who is curious about the whys and the hows of mathematics. So thanks a lot for watching. If you have any questions, comments, or concerns, feel free to leave them below or at my blog, mrmathclass.blogspot.com. I will see you guys next time.